Now we're going to talk about L'Hopital's rule. Everybody was excited about L'Hopital's rule at the beginning of the semester. So we'll just get into it. We'll finish it tomorrow. You guys know how many class periods are left before the end of the semester? So 13 counting today. Yeah. The semester is rapidly coming to an end. All right. So section 4.4 is on L'Hopital's rule. And so we're going back to evaluating limits, okay? But L'Hopital's rule under certain circumstances, right, lets us use the derivative, first derivative. So we got to define what L'Hopital's rule is first. So if we have the situation, new piece of chalk isn't cooperative. The limit as x approaches a of f of x is equal to the limit as x approaches a of g of x. They're both equal to 0, okay? Or we have the situation where their limits are equal to plus or minus infinity. And we have the condition that the limit as x approaches a of f prime of x over g prime of x. That's the ratio of their derivatives now, right? So here we're doing limit of f of x and g of x. Down here we're doing the limit of f prime, limit as x approaches a of f prime of x over g prime of x, okay? First derivative f of x over the first derivative g of x, okay? If that's equal to L, okay, then we have the following conclusion. The limit as x approaches a of f of x over g of x also equals L. Okay. So if f of x, remember in evaluating a limit, the first step is direct substitution, right? Plug a in for x, right? And so if we have the limit as x approaches a of f of x is equal to 0, and the limit as x approaches a of g of x is equal to 0, right? We call that 0 over 0 form, okay? On the other hand, if the limit of f of x as x approaches a is equal to plus or minus infinity, and the limit of g of x as x approaches a is equal to plus or minus infinity, we call that infinity over infinity form. So L'Hopital's rule applies to these two situations. where you got the 0 over 0 form or infinity over infinity form. Okay. It doesn't apply to any other situation. All right. Couple of notes on L'Hopital's rule. Okay. When we write as x approaches a, we're usually thinking of a real number, but x approaches a can be replaced with x approaching plus infinity or minus infinity or x approaching a from the right or x approaching a from the left. It doesn't have to be x approaching a real number, right? X can be going to infinity or minus infinity. It can be approaching a from the right and a from the left. Because you know when we're dealing with like the natural log function, okay, we can approach 0 from the right, but we can't approach 0 from the left. The value of L over here doesn't have to be a real number. It can be infinity, minus infinity, or any real number. So you know at the beginning of the semester when we were evaluating limits, algebraically from a graph, right, sometimes we'd write the limit as x approaches a, f of x is equal to plus infinity or minus infinity, okay? And we'll do an example to demonstrate number 3. L'Hopital's rule never allows us to conclude that the limit as x approaches a of f of x over g of x does not exist. We're going to do an example where we have a limit, it's like 0 over 0 form, and L'Hopital's rule doesn't give us an answer. Okay? And so when L'Hopital's rule doesn't give us an answer, you can't say, well, this limit doesn't exist. Okay? You got to use some other technique to define it. Okay? All right. So any questions on the definition of L'Hopital's rule? Okay. So L'Hopital's rule, we're taking a limit of f of x over g of x if it's in 0 over 0 form or infinity over infinity form, right? L'Hopital's rule allows us to still evaluate that limit. Okay. So in short, I'm going to leave this up here. I worked a couple examples before the end of the period. The limit as x approaches a of f of x over g of x, 0 over 0 form, or infinity over infinity form, is equal to the limit as x approaches a of f prime of x over g prime of x, as long as that limit exists. Okay, that limit has to exist first. Okay? All right. So let's evaluate the limit as x approaches 0. of e to the x minus e to the minus 2x over x. So, first step in evaluating limit, direct substitution, right? So we put 0 in for x. We have e to the 0 minus e to the minus 2 times 0 over 0, right? Well, what's e to the 0? And then we have e to the minus 2 times 0, minus 2 times 0 is 0. So we have minus e to the 0, right? Which is minus 1. And so now we have 0 over 0. So we can use L'Hopital's rule. Okay? Now, your textbook doesn't use anything to indicate it's using L'Hopital's rule, but I think it's a good idea to write something above the equal sign. I use LR for L'Hopital's rule. Something above the equal sign to indicate you're going to use this rule. Okay. L'Hopital's rule says I can differentiate the numerator and the denominator. It's 0 over 0 form. So derivative e to the x is e to the x. Then minus the derivative e to the minus 2x. Well, the derivative of e to the minus 2x by the chain rule is e to the minus 2x times the derivative of minus 2x, which is minus 2. So we have minus 2, which is plus 2, times e to the minus 2x. Convince yourself that is the derivative, or I'm wrong. And then we differentiate the denominator. Derivative of x is 1. So this simplifies to the limit as x approaches 0 of e to the x plus 2 times e to the minus 2x. Then I might want to put that in parentheses. Now you can do the direct substitution. You have e to the 0 plus 2 times e to the minus 2 times 0. Well, e to the 0 is 1. E to the minus 2 times 0 is e to the 0, which is 1. So we have 1 plus 2 times 1, which is 3. So the limit as h approaches 0 of this function is equal to 3. Okay. The closer the value of x is to 0, the closer the value of this function is to plus 3. Okay. So that would be like the y-intercept. There'd be a hole at the point 0, 3. It wouldn't be a y-intercept, but there would be a hole on the y-axis at 0, 3. So we'll work some more examples first thing tomorrow. Okay? Have a good day.